Utility companies sometimes operate under different standards than what is commonly found in the National Electrical Code, or NEC. There are several reasons for this difference, spanning from historical context to practical considerations. Firstly, historical reasons play a significant role. Utility companies often inherited existing infrastructure that predates the establishment of the NEC. These pre-existing systems were built to earlier standards, and retrofitting them to comply with current NEC requirements across vast networks can be exceptionally challenging. Secondly, the complexity and scale of utility operations pose unique challenges. Utility systems are incredibly vast and complex, covering large geographical areas and serving numerous customers. Adapting these massive systems to new codes and regulations can be a logistically difficult undertaking. Thirdly, legal exemptions exist in certain jurisdictions. Specific statutes or regulations may exempt utility companies from certain NEC provisions. Additionally, local governments may grant exemptions based on the unique characteristics of the utility systems within their jurisdiction. Fourthly, technical considerations come into play. Quickly updating existing systems to meet new NEC requirements could inadvertently introduce new safety hazards. Moreover, utility systems must maintain interoperability with existing equipment and infrastructure to ensure reliable service. Replacing or modifying equipment to strictly adhere to NEC standards could disrupt this interoperability. Fifthly, cost implications are substantial. Implementing new NEC requirements across an entire utility network can be expensive and time-consuming. The financial burden of such widespread upgrades could be passed on to consumers. Sixthly, regulatory oversight is a key factor. Utility companies are typically subject to independent regulatory oversight by state or federal agencies. These agencies ensure that utilities operate safely and efficiently, often using their own set of standards and guidelines. The National Fire Protection Association, or NFPA, which administers the NEC, recognizes the unique challenges faced by utility companies. The NFPA provides alternative compliance options and acknowledges the need for flexibility in certain situations. Seventhly, industry standards are prevalent. Utility companies have developed their own industry standards, such as those from the Institute of Electrical and Electronics Engineers, or IEE. These standards address the specific needs and challenges of utility operations, often going beyond the scope of the NEC. Utility companies also collaborate with NEC code authorities to develop and amend code provisions, ensuring that industry concerns are addressed while maintaining safety. Efforts are continuously made to address concerns related to electrical safety in utility systems. The NEC includes provisions for protecting underground splice faults from water intrusion. Fuse coordination is carefully managed by utility companies to prevent faults from damaging equipment. Utility companies perform regular maintenance and inspections to identify and address potential hazards. It's crucial to recognize that even when exempt from certain NEC provisions, utility companies remain responsible for operating their systems safely and reliably. They rely on a combination of industry standards, best practices, and regulatory oversight to ensure the safety and reliability of their electrical systems. It's also worth noting some specific examples of how these factors impact practical applications. Consider an older neighborhood with underground electrical distribution. The original installation might have used direct buried cables that don't meet current NEC standards for burial depth or cable type. Requiring the utility to excavate and replace all of these cables immediately would be incredibly disruptive and costly, potentially without significantly improving safety, especially if the existing system has been operating reliably for decades. Instead, the utility might focus on enhanced monitoring and maintenance of the existing system while gradually upgrading infrastructure during planned replacements. Another example involves substation equipment. Substations often contain specialized equipment designed and built to ANSI standards which may differ in some aspects from NEC requirements. These differences may relate to clearances, grounding practices, or enclosure types. While the NEC provides general guidelines for electrical installations, the ANSI standards are specifically tailored to the high voltage, high current environment of substations. Retrofitting an entire substation to strictly adhere to the NEC could compromise the performance and reliability of the equipment. Another critical area is coordination and protection. Utility systems rely on complex protection schemes involving fuses, circuit breakers, and relays to isolate faults and prevent widespread outages. These protection schemes are designed to operate in a coordinated manner across the entire system. Changing the characteristics of one component to comply with a specific NEC requirement could disrupt the coordination of the entire system, potentially leading to more extensive outages or equipment damage. Therefore, utility companies often employ sophisticated engineering studies to ensure that their protection schemes are properly coordinated, even if they deviate from certain NEC guidelines. Furthermore, consider the issue of arc flash hazards. Arc flash is a dangerous phenomenon that can occur in electrical equipment, releasing tremendous amounts of energy and causing severe burns or even death. The NEC contains extensive requirements for arc flash protection, including labeling, personal protective equipment, and engineering controls. However, utility companies often have their own arc flash programs that are tailored to the specific hazards of their equipment and operating practices. These programs may incorporate advanced techniques such as remote racking of circuit breakers, insulated tools, and specialized training. While the NEC provides a valuable framework for arc flash protection, utility companies often go above and beyond these requirements to ensure the safety of their workers. The regulatory environment also plays a crucial role. Utility companies are subject to oversight by various regulatory agencies, such as state public utility commissions and the Federal Energy Regulatory Commission, or FERC. These agencies set standards for reliability, safety, and customer service. They also conduct audits and investigations to ensure that utilities are complying with these standards. In some cases, these regulatory agencies may grant waivers or exemptions from certain NEC requirements if they determine that compliance is not feasible or would compromise the reliability of the electrical system. These waivers are typically granted on a case-by-case basis and are subject to strict conditions. It is important to reiterate that the NEC serves as a valuable guide for electrical installations, but it is not always directly applicable to the unique challenges and constraints faced by utility companies. These companies operate complex, interconnected systems that require specialized engineering expertise, advanced protection schemes, and rigorous safety protocols. While they may be exempt from certain NEC provisions, they are still responsible for ensuring the safety and reliability of their electrical systems, and they often do so by adhering to industry standards, best practices, and regulatory requirements. One more practical aspect to consider involves grounding and bonding. The NEC has detailed requirements for grounding and bonding electrical systems to minimize the risk of electric shock and fire. These requirements are designed primarily for residential, commercial, and industrial buildings. However, utility systems often have unique grounding configurations that differ from those specified in NEC. For example, utility substations may use a grid of interconnected ground rods and buried conductors to create a low-impedance ground path. This grounding grid is designed to dissipate fault currents quickly and minimize the risk of ground potential rise, which can be hazardous to personnel and equipment. The NEC also addresses temporary wiring. Utilities often need to install temporary wiring for maintenance, repairs, or emergency situations. The NEC has specific requirements for temporary wiring, including the use of ground fault circuit interrupters, or GFCIs, and proper support and protection of conductors. Utility companies typically have their own procedures for temporary wiring that may differ from the NEC requirements in some respects. These procedures are designed to ensure the safety of workers and the public while minimizing the risk of electrical hazards. Another factor is the National Electrical Safety Code, or NEC. The NEC is a separate standard that covers the construction, operation, and maintenance of electrical power and communication lines. The NEC is widely used by utility companies in the United States and is often referenced in state and local regulations. While the NEC focuses primarily on the wiring of buildings and structures, the NEC addresses the specific hazards associated with overhead and underground power lines, including clearances, grounding and mechanical strength. The NEC also deals with emergency systems. Emergency systems are designed to provide power to critical loads during a power outage. The NEC has specific requirements for emergency systems, including the use of automatic transfer switches, backup generators, and uninterruptible power supplies, or UPSs. Utility companies also have emergency response plans in place to deal with power outages caused by storms, equipment failures, or other events. These plans typically involve coordinating with local emergency responders, restoring power to critical facilities, and communicating with customers. The NEC specifies requirements for hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. The NEC has detailed requirements for electrical equipment installed in hazardous locations, including the use of explosion-proof enclosures, intrinsically safe circuits, and other specialized equipment. Utility companies may have hazardous locations within their facilities, such as areas where natural gas is stored or processed. These areas must be designed and maintained in accordance with the NEC and other applicable standards. The NEC specifies requirements for electrical testing. Electrical testing is essential for ensuring the safety and reliability of electrical systems. The NEC requires that certain electrical equipment be tested periodically, including circuit breakers, transformers, and protective relays. Utility companies also conduct extensive testing of their equipment and systems to identify potential problems and prevent failures. This testing may include insulation resistance testing, transformer turns ratio testing, and protective relay calibration. The NEC mentions requirements for renewable energy systems. Renewable energy systems, such as solar photovoltaic, or PV, and wind power, are becoming increasingly common. The NEC has specific requirements for the installation and operation of renewable energy systems, including grounding, overcurrent protection, and disconnecting means. Utility companies are also involved in the integration of renewable energy systems into the electrical grid. This integration requires careful planning and coordination to ensure that the grid remains stable and reliable. The NEC has information about energy efficiency. Energy efficiency is becoming increasingly important as concerns about climate change and energy costs grow. The NEC has some requirements for energy efficiency, such as requiring the use of energy-efficient lighting and motors. Utility companies also promote energy efficiency through various programs and incentives. These programs may include rebates for energy-efficient appliances, energy audits, and educational campaigns. Also, utility companies are often responsible for maintaining the street lighting in their service areas. Street lighting is essential for public safety, especially at night. The NEC has some requirements for street lighting, such as requiring the use of weatherproof enclosures and proper grounding. Utility companies also have their own standards for street lighting, including the type of fixtures used, the spacing of the lights, and the level of illumination. Lastly, the NEC also mentions requirements for communication systems. Communication systems are essential for the operation of modern electrical systems. Utility companies rely on communication systems to monitor and control their equipment, coordinate maintenance activities, and communicate with customers. The NEC has some requirements for communication systems, such as requiring the use of surge protection and proper grounding. Utility companies also have their own standards for communication systems, including the type of cabling used, the protocols used for data transmission, and the security measures in place to protect the systems from cyber attacks.